Hello everyone and welcome to the virtual Smart Energy Forum organized by Business Finland. My name is Patrick Farkas. I'm the Market Development Manager at Wärtsilä. Wärtsilä is an international energy and marine company with strong Finnish roots. We are developing and integrating energy solutions that build a more intelligent, resilient and flexible energy infrastructure. Today, I will briefly talk about the decarbonization prospects for the Middle East and will showcase some immediate and long-term solutions. Fight against climate change is entering a new chapter, and decarbonization is one of the main frontiers. After the COVID pandemic, decarbonization can be the next global battle, which will hopefully unite nations to take joint action in order to avoid climate catastrophe. As of today, more than 40 countries already made some commitments for decarbonization. As first one in the OPEC, the UAE is considering to commit to become a net carbon zero economy by 2050, which is an important milestone because it well represents that decarbonization is getting high on the agenda even in the Middle East. According to the World Bank, 5 out of the 6 Gulf Cooperation Council countries are among the top 10 largest CO2 emitters on a per capita basis. So it shows that decarbonization potential is huge and actions are needed across every sector in energy, transportation and industry as well. Today, I will focus on the decarbonization of the electricity sector, which is currently responsible for 20% of the global energy use, and its share is expected to further grow up to 50% by the middle of the century. So first, let's take a look at the GCC countries' clean energy targets. All 6 GCC countries are having some kind of renewable targets. Most of the countries are planning to generate at least 20% of their power on a renewable basis. As a consequence, the region will see massive amount of renewable energy addition over the next couple of years. The UAE is having the most ambitious targets in terms of share of renewable energy in the generation mix, while in the near term we believe that Saudi Arabia will add the most amount or the highest amount of megawatts of clean energy capacity. Interestingly, more than half of the GCC countries are also having decarbonization targets. Some of them are related to funding of the of this industry, while others define concrete carbon reduction figures. On the other hand, if we take a look at the current energy landscape, the picture is not that good. Despite the ambitious plans, the region's power generation is still heavily dominated by fossil fuels, and the penetration of renewables is below 5% in case of 5 out of the 6 GCC countries. As of today, there is approximately 4 gigawatt renewable energy capacity operating in the GCC, which would be enough to cover roughly 3% of the peak demand of the region. By the end of the decade, the installed renewable capacity will grow 13-fold, which will make up to 30 to 50% renewable capacity compared to the peak load of the GCC countries. So the decarbonization, it's a complex process and there is no silver bullet solution for it. Multiple technologies and policies will shape it. In the Middle East, the first and most obvious solution is to start deploying massive amount of solar PV. The region has a competitive advantage as it has excellent solar conditions, plenty of land to deploy solar, a relatively modern power transmission infrastructure, and also relatively low cost of capital. All these factors can contribute in making the region a renewable powerhouse. Although the million-dollar question is whether solar PV alone will be sufficient to deliver the desired decarbonization targets for the region. Wärtsilä is developing a demonstration synthetic model for the Middle East to study this subject. We are investigating and comparing different expansion scenarios to better understand the potential decarbonization trajectories. The modeled synthetic system intends to represent the characteristics of the region in terms of the demand. We assume a quite high seasonal difference in demand. Also, in terms of the generation cocktail, the region is, as of today, is dominated by gas-fired combined cycle gas turbines. We use the region-specific fuel and investment costs, and needless to say, the regional renewable profiles in order to best capture the opportunities of renewables. So next, I would like to show you two snapshots of this representative system. The first snapshot represents the near future, in which this Middle Eastern sample country already built as much solar as 20% of its peak load. So imagine, for example, a 10 gigawatt system with 2 gigawatt solar PV in it. In this case, the share of renewable energy generation in the total power mix will be 10%, and this amount of solar PV can help decrease carbon emission of the system by 9%. 10% BRE share is where UAE stands today, but as I showed you, most countries are planning to double this number by the end of this decade. I would like to add, though, that there is additional decarbonization potential here without building an additional single solar cell. If you add an energy storage facility, which is sized according to the reserve requirements of your power grid, it will help you to unlock an additional 5% carbon reduction potential, which is quite a substantial upside compared to the no energy storage scenario. Well, how come that we have the same amount of renewable energy, but we still decrease the carbon footprint of this system? Well, in this model, in case of 20% solar generation, this amount of solar PV will be absorbed by the current system without major curtailment issues. In this case, the battery is providing ancillary services to the grid. The battery will optimize the reserves and displace thermal contingencies and improve the overall efficiency of the system. Therefore, the rest of the grid will use less fuel and emit less carbon dioxide. As the grid requirements are changing, the functionality of the battery storage can follow, and it can switch between jobs as the grid requirements require. So now let's take a bigger jump and imagine that the installed solar PV capacity is at par with the peak demand. In this case, the theoretical renewable energy generation will be nearly 50%, although due to the demand seasonality and the solar PV generation profile, the actual renewable penetration will be only 29% in this system. As I said, the battery can change the functionality, so using the exact same battery that I showed you in the previous case can assist you to further boost your renewable penetration from 29 to 38% in this synthetic model representing the Middle East, and also boosting the renewable, the carbon reduction by almost 50%. And the best thing is, if you add energy storage to this example system, it will even decrease the levelized cost of electricity. So in short, energy storage today offers an available and scalable solution which is future-proof and can accelerate your decarbonization. This simulation demonstrates the positive effect of batteries in power systems similar to the ones in the Middle East. Battery storage will improve the resiliency of the grid by introducing fast reacting and balancing capability. Furthermore, energy storage can also supply synthetic or digital inertia that responds to a frequency signal in a fraction of a second and preventing a frequency problem before the problem escalates. All these critical grid services are getting more and more valuable globally as the penetration of solar and wind increases in modern power systems. Nothing demonstrates this better than our latest deal with Australian utility AGL. This summer we signed a contract to deliver a 200 megawatt 1-hour battery plant. The plant will initially operate as a grid firming battery to provide critical grid services for the power system in order to allow the unconstrained injection of renewables into the grid. This facility will be the largest grid firming battery in Australia and the second largest battery facility ever built in the continent. AGL is targeting to increase the share of renewables to 34% by 2024, so this asset will also support this initiative. Battery storage hasn't broken ground in the Middle East yet. There are some pilot and test facilities in the UAE or in Qatar. However, the industry-wide expansion, such as we've seen in the US or in Europe, still yet to come. The new Saudi Giga projects, like the Red Sea Development Project or NEOM, plan to deploy massive amount of energy storage. So hopefully these initiatives may break the ground for battery storage in the Middle East. As I showed you previously, 40% renewable share and 40% decarbonization was achievable even in our demo model with only with solar PV and battery storage. And I can tell you that this number can be further improved with the additional optimization of the expansion plan or with the consideration of adding more flexibility to the system. However, we are still far away from the carbon neutral energy system. In the last part, I will show you what we believe to be the last missing piece of the puzzle. Power-to-X and future fuels can potentially bring the final push for the full energy transition. Power-to-X is an umbrella term for various emerging solutions. It basically comprises the most exciting, game-changing technologies in the industry. Simply put, Power-to-X is a process that allows you the production of carbon-neutral synthetic fuels with the use of renewable energy. By capturing CO2 from the air and combining it with green hydrogen, a wide range of synthetic fuels can be produced. These synthetic fuels are also called future fuels or e-fuels. The process is called Power-to-X, where X marks a wide variety of fuels, such as synthetic methane, synthetic methanol, or even e-kerosene can be produced with this one. However, in terms of energy requirement, we see synthetic methane and synthetic methanol production to be the most cost efficient. It's important to emphasize that future fuels that are produced here are identical to the ones are used today in terms of chemical composition. Therefore, they can be used in today's energy infrastructure. You don't need to build a new pipeline, energy storage, or you don't need to convert your power plants. They can be used in the existing infrastructure. And as they are produced from the carbon dioxide captured from the air, once you burn them, you will not add additional carbon dioxide emission to the atmosphere. Despite the pragmatic solution Power-to-X offers, what we see that the utilization of hydrogen is rather in the center of attention in the Middle East. Hydrogen production is part of the Power-to-X process. Hydrogen is often called the oil of tomorrow. The production and utilization of hydrogen is by far the hottest topic in the energy industry today. Green hydrogen is projected to cover 7% of the global energy demand by 2050. And as of today, more than 40 countries have committed to certain hydrogen strategy to facilitate the deployment of this technology. Green hydrogen is offering interesting possibilities for decarbonization in several sectors, in the energy industry, in chemical sector, in heavy industry, or in transportation. As of today, most of the hydrogen is consumed in fertilizer production and in steel manufacturing. So these sectors can represent an immediate deployment opportunity for green hydrogen. In the power sector, we see two main potential roles for hydrogen in the future. One is, as I showed you, can be the feedstock for the creation of future fuels. The other option or the other opportunity is that hydrogen to be burned directly in power plants in the future. Either way, it will offer a carbon neutral process, and hopefully it will be able to solve the long-term energy storage issue. We have started looking into the utilization of hydrogen in our engines already 20 years ago. However, the development really accelerated over the past 5 years as the idea gained more popularity and new technologies emerged. Currently, some of our engines are capable to combust hydrogen blends with up to 25% hydrogen content. This summer, we started testing running engines on purely hydrogen, and according to our timeline, we expect to have a pure hydrogen engine ready by 2025. We are also running engine testing for ammonia and methanol as well, which could support the decarbonization of the shipping industry. For the marine market, we expect to have an engine running on ammonia blend already this year, and to have a full ammonia-ready engine concept by 2023. Wärtsilä is also busy developing the Power-to-X supply chain and ecosystem. So we constantly seek new partnerships. So we teamed up with promising rising stars of the energy industry, such as Solater Power, that specializes on carbon capture, or Q-Power, who developed a unique methanizer solution. This summer, Wärtsilä also signed a co-development agreement with Vanta Energy. Together with the Finnish utility, we will build and develop Finland's largest synthetic gas production facility. This facility will produce synthetic methane from renewable energy sources and from carbon dioxide carbon emission of an existing waste-to-energy plant in Finland. And that synthetic methane will be used in transportation and also in district heating over the winter heating peaks. In the Middle East, the focus is on hydrogen. The International Energy Agency predicts that the GCC can become one of the lowest cost green hydrogen producing regions in the world. The region has a high potential for localization of green hydrogen production, driven by positive signs both on the production and on the consumption end. According to the MENA Hydrogen Alliance, hydrogen production can lead up to $70 to $200 billion annual revenues for the GCC, which can offset the declining revenues from hydrocarbon exports. And once the hydrogen industry is scaled up, it will bring an additional 1 million new jobs to the region. There are some interesting projects already being developed in the region. As of today, the world's largest green hydrogen plant will be built in Saudi Arabia under the NEOM Giga project. And also, for example, Oman is planning to launch a giga hydrogen and ammonia plant in the port of Duqm. Other than the concrete projects, there are industry partnerships that intend to facilitate the development of the hydrogen industry across several sectors. In cooperation with Solitaire Power and Q Power, Wärtsilä will showcase its Power to X competencies in a Finnish pavilion at Dubai World Expo. This demo unit will be capturing carbon dioxide from the air of the Finnish pavilion and transform it to a synthetic fuel. This carbon neutral synthetic methane will be used to provide clean power to make coffee for the visitors of the pavilion. So if you happen to be there, please visit us and be our guest for a cup of carbon neutral coffee made out of thin air. Thank you very much for your attention, and we look forward to seeing you at the expo.